Hello everyone, my name is Vinod from AML department. Today I am going to present you about my topic AttendX, which is a face recognition based attendance system developed under the guidance of Mr. Sarunanti, Assistant Professor of AML department, Savita Engineering College. This project focuses on automatic attendance using artificial intelligence and computer vision. So our agenda is in this presentation, I will cover the introduction, problem statement, scope, methodology used, and system design implemented, and the implementation, algorithm, results, and further enhancement. So about the introduction, the traditional attendance methods like manual roll calls consumes valuable class times. QR code and biometric systems can be misused or an inconvenience. Our system, AttendX, uses real-time face recognition to automatically mark attendance. It is accurate, contactless, save times, and store attendance digitally. Statement of the problem. Manual attendance takes 5 to 10 minutes per class. QR codes can be shared and biometric system require physical contact. There is no centralized way to attendance analyze data, so our objective is to build an AI-based contactless attendance system that recognizes faces in real time and log attendance automatically. Our scope of the project. The scope includes developing an automated system using OpenCV and deep learning models. A Flask-based web interface is used to view attendance. The system supports face data collection, recognition, and daily CSV report generation. It is suitable for school, colleges, and training institutes. This includes in-phase data creation and encoding using deep learning model, and exclusively we are further plan to bring a mobile app version with multi-campus cloud dashboard, liveness detection, etc. So methodology implemented. Space data collection capture multiple students at the time and give it to the preprocessor where each image is resized, detect face, and remove invalid samples. Further which the faces undergo an encoding system where the face images are embedded. That embedded systems are used to recognize the faces of each students and compare it with the live feed. This live feed and the encoded system will give an pickle file from which the student's data is fetched and marked attendance. And web app development. Flash-based UA for data collection and attendance, and testing and validation verify recognition accuracy and speed. Detailed workflow. First, the student image is captured through the webcam and the face is detected using CNN-based detectors. Then an embedding of face recognition that based on the face recognition library, which is stored in an encoding pickle file. That pickle file is used to compare with the live feed, later which a log is created. That log is used to create a CSV file, which is later used for attendance marking. This is our architecture diagram flow, where the students and the live feed go into recognition model. In this, some pre-processing steps such as feature extraction and encoding will happen. That encoding will send to the matching algorithm, where the previously stored face of the students will be compared with the live feed from which the attendance is marked. This marked attendance will send to the web dashboard where the real-time view of the data can be accessed by the teachers and so on. Design use case. The UML diagram consists of graphical representation of our system architecture showing how the external users interfere with our system users. The individual who interacts with the system. Example students, administrator or outsider, and then data collection, market and peer report are inside. First, the admin give access to the user to register the student data and manage the student data, and the admin will view attendance log, generate report, etc. This is the further breakdown of UML diagram and design class diagram. In this diagram, this is used to represent the class of the face recognition system, where the class is a representation of object in many ways. It is simply a template from which the objects are created. Although there are individual number of systems in the model, the only one class which is stand out are students, which would represent the entire collection of individuals whose attendance is being tracked, and other classes. Attendance system which handles the overall recognition and log process. This complete cycle which is used to recognize a student's face and from which the attendance is marked, which is a sequence diagram. First, the students appear in view, the information is stored, and the live frame is sent to the embedding system from which the date and phase of the students is related. This will be keep on in a loop so that the many students can come into an time frames. Their respective phases are encoded, from which it is compared to the existing user database, which is used to mark the attendance of the particular student, and the CSV file is logged. This is a further extension of the sequence diagram. And the administrator start enrolling the session. After enrollment of the section, the web camera activates the camera. The live feed will be recorded. This live feed will be used to embed the each time frame. With these frames are then further go under embedding, which is used to compare the previously captured image with an existing photos, which is used to confirmation and display the success message. Algorithm used. We have used a major algorithm such as you look only once model, where it is used for detecting face and creating a bounding box around the each students. So it will be used to capture the student's image in real time and send it to the precursor. As it is using GPU for the computational process, it will be more efficient than using the RAM and so on. And we also use marginal based embedding model, which is a unique low dimension based embedding, as we are trying to create a model which is lightweight and can be used in various mobile devices or laptop devices. So it should be lightweight in order to perform in all other environment. So we are using marginal based embedding model, which is unique, and low dimension based embedding, which results in a high accurate real-time comparison between the live face and the stored encoding. Example, when a student faces proceed, it generate embedding is compared against the stored embedding of all enrolled students. The margin ensure that only the very close confidence match results in students being marked as present. So this is also used in liveness detection. So when the students come near the camera only, it will be record the attendance. Hardware and software selection for the input. We are inbuilt system which is an web camera or web sensor used to capture real-time image of the students, and processor unit which is also come inbuilt in laptops and so on. So the base recommendation is to have Core i3 processor, so it will be easy for the processor to process the image and give a result in real time. These NVIDIA Jetson Nano and Raspberry Pi are completely optional. We are mentioned in this PPT so that it can be also developed as an hardware project in the future cases. Display and output, which can it is a monitor screen to view the web dashboard, which is created using Flask, and connectivity. Wi-Fi is most recommended to transfer attendance data to the system dashboard. And software algorithm, the programming language we have utilized is Python for backend logic and leveraging rich AML ecosystem. For web framework, we have used Flask for build the lightweight web-based dashboards for students viewing and administration, and implemented computer vision using OpenCV, which is used to utilize the functionality of cameras and time frames of the images that are used to collected by the embedding systems. And for face detection, we have used YOLO version 7, which is accurately locate faces within the video time frame using the bounding boxes. Face recognition model, which is an inbuilt function given by the face recognition library, utilizing Dlib, FaceNet, and ArcFace to extract unique 128 dimensional face embedding and perform the matching. As we are taking 128 dimensional of the embedding system, it will be useful for the model to learn the hidden patterns in the face. Though, so why we are basically implementing is this is to create a model that will be able to perform more efficiently even when subjected to many external factors such as sunlight or shortage of intensity of light, so on. So for the data storage, which is a pickle file, why we haven't gone for an major storage type like MongoDB? Because pickle files are easy to access, so we do not need to encode the face each time we see. Only one encodation is enough. This encodation is stored in the pickle file format, and from which the embedded system will try to analyze and mark attendance. For the front end, standard web technology like HTML, CSS, JavaScript are used, and also React. And implementation, the core technology is to use Python, OpenCV, and Python as handling deep learning framework. And model manage the pre-trained YOLO 7 model weightness and student face recognition dataset. Face recognition is made possible using YOLO 7 encoding and training recognition real-time output. So code snippet used face recognition logic. This logic is utilized in the face recognize collection of face data, and this logic is utilized in face encoding logic where the image is loaded and then face encoding is performed, which is apparent to pickle file, which is non encoding. And recognition logic, which matches the already captured image with the live feed. After the live feed, it will be, so this is the output template. This is the main interface of the system that we are chosen between the core operation, which is the basic UI of the face recognition system. And this is the collection phase where the students' images are collected initially and then encoding. These collected images undergo an encoding process from which the pattern of the facial structure is learned and stored as a pickle object. Then the attendance is marked using live camera feed. Here we can see the input, and here the CSV file is generated and with the timestamp. We can also see the test cases, which is capture page students. These cases all should be passed in order to the success of the project, and the results are almost 94% accurate, which is predicted using accuracy model. And speed detection is less than 20 fps. Because of the computational efficiency, we have reduced 20 fps so that it will be working any type of models. And attendance logging delay is less than 1 second. Within the fraction of second when the model is bounded our faces, it will be converted, updated to the series file. And finally, the conclusion: the attendance system successfully automate attendance using AI-based face recognition. It reduces manual effects such as roll call based or QR code, which is a manual effect. Simply giving our face to the model will mark our attendance, which is also given a constraint that a student must must be present in order to get his attendance. And the future work we have planned to implement is a mobile app for faculty so that they can able to review attendance in their mobile itself, and cloud-based dashboard for multi-classroom analysis. So now we have only created an application for a single classroom. For multi-classroom, we need a large data set, large database to store all the values, and liveness detection, which is anti-spoofing, monitoring the whole 2 hour section from which the attendance is marked based on the involvement of the student. Integration with ERP platforms. With the existing ERP platform, we are planning to integrate our project. And these are the reference papers we have explored. A FaceNet, a unified embedding for face recognition model, and histogram, and so on. So these are the reference paper we have. Any questions? So, and I also like to show our project, so which is in VS Code.